All right, now that you know some vocabulary, we should be able to simplify these expressions. And that's what this lesson is about. This is part 2 of 6.7. I have 5 different expressions up here that we're going to simplify. All of these have one variable, okay, just one, like it's x. X is the same variable in each of these. If something has an x and a y, or an a and a b, or a c and a d, then it has 2 variables. If it has a x, y, and z, then it has 3 variables. Okay, but these just have one variable. So let's look here. How can I put these together? Now, this is multiplication. The parentheses tells me I'm separated by if I'm separated by parentheses, I multiply them. Now, 4 times 6x, they're not like terms, but it's okay, and I can put them together because it's not addition or subtraction. Um, and I'll show you how I can put these together. The reason why I can do this is with the um, associative and commutative properties. Because basically what this is, it's 4 times 6 times x, wanting us to do that first. But associative property tells me 4 times 6 times x could also be like that because of the multiplication. So if I do it like this, 4 times 6 is 24 times x, and 24 times x is the same as 24x. So right here, my answer to simplify this is 24x. And with multiplication, it's just 3 multiplications. And you can always put all the multiplication together. So when you have addition, subtraction, it gets tricky. Okay? The other thing that I think about like this, it's almost like I'm distributing it. I go like this. There's just nothing more to distribute it. You just distribute it to this one term here. Or not even a term. This is the one term. Nothing separated by addition and subtraction. So your one term is 4 times 6 times x. And because it's one term, you can put it all together. Okay? That's 24x. Let's keep going. Now I have 3 times x times 11. My associative property says, well, the commutative property also tells me I can move some things around. So I'm going to move some things around here because it's all multiplication. So I'm going to do x times 3 times 11. Okay. Or I could go 11 times 3 times x. Doesn't matter how I put it, it's all the same thing. Just multiplying it together. This way, it's 11 times 3 is 33 times x, which is the same as 33x. Okay? I could even put this together, 33x times 11. 33x times 11. Because it's multiplication, it's one term. And so you put it together. There's no addition or subtraction that separate it. Okay? Now, let's go over here. We do have addition here. So I have a term there, I have a term there, I have a term there. I have 3 terms. Now, because they're different terms, I can only put them together if they're like terms. X, 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 they're all the same variable. They're like terms. So I add them together. I have 1x, 2x, and 3x. This is a much simpler way to say this. Okay? And you kind of think about, well, how many x's do I have? I have one, then I have another one, and another one. So I do have 3 x's. Yeah. If you ever want to check to see if it equals, make up a variable. Like, I'm going to say x is 3. X is 3. So 3 plus 3 plus 3, that equals 9. Is that the same as 3 times 3? Yeah. Okay. So if that works with x being anything, then it means I've simplified it, and I'm good. Okay. Let's go here. I have different terms because they're separated by addition. Here's a term. Here's a term. Here's a term. Now, I want to simplify it. I want to put things together as much as I can. It's like packing a house up. You want to be the most efficient. Put as much as you can in a box. Put everything that's like together. You're not going to put your kitchen stuff in with your bathroom stuff in, with your bedroom stuff, with the family room stuff, because then when you unpack it, you gotta go here, 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 here. You need like stuff together. Okay? So I'm looking at my three terms. I want to pack the like stuff together. My like terms are 7x and just x. So when I put my 7x and my x in the box, I now have 8x. But then I have this constant here, which is 8. But I better bring that along because I need that. That's a part of this thing. So 8x plus 8. Now I just have two terms instead of three terms. It's simpler. Yay. But are they like terms? No. One has a variable x, one is a constant, has no variable. So it's as simple as it can get. None of these can be put together. Okay. Let's look at this one. Okay. This one I need to do, so I do the parentheses first, x plus 1. Separated by a plus means I have two terms here, x and y. Are they like? No, they're different. So I can't put those together, so I can't do that. But I can distribute this 3 because this 3 is multiplying to everything in here. So I can do that, and I can do that. 3 times x is the same as 3x, okay? And then plus 3 times 1 is 3, and then I bring everything else down, okay? So I just distributed this over here and simplified this. But now I want to simplify it even more if I can. I see 3 terms separated by addition. 1, 2, 3. I find my like terms. Like terms would be this 3x and this x. Put them together. 4x, and I put my 3 down there. 4x plus 3. Okay? So isn't it much simpler? Instead of saying 3 parentheses x plus 1 and parentheses plus x, I can put this together in a certain way and say, oh, just do 4x plus 3. Here I have two terms, where here I had 1, 2, 3. Okay? Simplify, simplify, simplify. Okay, now let's add a term, and we're also going to talk about factoring too, just for fun. Okay, so here I have some terms separated by addition. Looks like I have a term here, a term here, and a term here. Okay. Now, these are in parentheses. So I look, can I put these together? Are they like terms? No, I can't put them together. Because I can't put them together, it's done. So now, because of associative property, I can add things differently. Commutative property tells me I can put things differently because it's all addition. If it'd be subtraction, I can't. Okay? But, so what I can do is I'm going to put this 14y and this 22y, because those are my like terms. My like terms, this one and this one, they both have a y. So instead of saying 14 times y and then add it to 22 times y, let's just put the numbers together and then times it by y. So that would be 36y. It's going to get me the same answer. It's just simpler. Instead of doing a problem here and a problem here, I'll do 36 times y. But then I have this x, which I can't leave behind. 36y plus x. So now I have two terms, which is simpler than three terms. 1, 2, 3. I can't put these together because one's a y, one's an x. They're not like terms. Let's look here. I see that I have the 7 here against a parentheses. I'm going to see if I can put this together in here because it'd be easier to put it together and then multiply by 7. I have two terms. This is a term, this is a term. Are they like terms? No. This is an x, this is a y. Not like. Okay, so I can't put those together, so now I'm just going to distribute the 7 to each side. 7 times 3x gives me 21 x's plus 7 times y, 7 times 1y, or 7 times y, is just going to give me 7 y's. Okay? So now I'm down to, this is a term, this is a term. I'm looking for like terms because when they're like terms, I can put them together. I have an x here and a y here. They are not like terms. So 21x plus 7y is as simple as I get. I take it from here, distribute it, and there. If this was an x, I could have put them together. If this was a y, I could have put them together. But they're different variables, so they're not like terms. Okay. This, I could factor this, find the greatest common factor, and go back to here, and it would be 7. Okay? So here I went like this to here. I'm going to do the opposite here. Whenever it says to factor something, you find the GCF, and then you factor it out. We did a little bit of this, but I want to show you how the variable goes along with it. Okay? So 12 and 8. 8 is my smaller number, so I'm going to do 8. 1, 8, 2, 4, 3 does not. Okay? So now I got to see which goes into 12. 8 does not, but 4 does. So 4 is my greatest common factor. That's going to be on the outside of the parentheses. Now, how many times does 4 go into 12? 3. The x goes with it. And then how many times does 4 go into 8? 2 times. Okay? And you get 4 parentheses, 3x plus 2 and parentheses. I factored it out. Okay? Now, if this had a y, I still couldn't put those together, but now the y goes with it. Okay? So if there's two variables here, you still find the greatest common factor of the numbers, or the coefficients, you could say. And then you put it here, and then you find out how many factors, how does it go into this one, put it along, how many does it go into that one, put that right there, okay? All right, this is a lot. I want you to take your time. I want you to practice this with the guided practice. Watch, I do more of them. I really want you to have your book open, watch the guided practice, listen to me, do some, write down questions if you have questions, come see me, and then do the independent practice and then some extra practice. But this is really important. Oh, sorry, I thought I was way off time, but just perfect. Okay, this is really important because you're going to be asked to simplify expressions, especially in the next chapter. We're going to be distributing and simplifying it, and you need to know what a term is and how to put like terms together. All right, good luck.